PAM development based on teleport. My name is Anton Zabelenko. I am responsible for cybersecurity in Wildberries, and Pavel Prachomets is responsible for infrastructural security in Wildberries. But before we start, let us define what PAM is about, what we're going to speak about. In essence, in the context of our today's presentation, PAM is the Privileged Access System Management. Pavel, you took my clicker, so change the slides, please. In the context of our today's report, PAM, this is a Privileged Access Management, which manages privileged access to different virtual machines, servers, databases, etc., etc. So why? I specify that because PAM abbreviation sometimes could be interpreted as pluggable authentication module, which helps to make extra authentication module, but today we're speaking about the privileged access management. This is what PAM stands for. After I told you about what we are going to speak about, you may ask a legitimate question: what the problem is about, and why. Actually, we decided to tell you about that because there are a lot of proprietary in-house solutions, and you may say, take it or buy it and stop telling us about that, but it is not as simple as that. So Pavel, tell us what the problem is about. In essence, that's a very good question. Most of PAM solutions that are available on the market are designed for the classical Windows infrastructure. In essence, they would have a total different ideology, different approaches, and they would misregard certain Linux features that could be used in order to fix the problems. So it means that these solutions are not fitting Linux very well. So what I would like to discuss with you, first of all, what criteria can be set for PAM infrastructure that we are going to use for Linux. Second, we'll tell you about certain approaches and which way we decided to go, and we will tell you how we introduced that and what difficulties we run into, and at the end of the day we will tell you how safe it may be. We set a lot of criteria to the PAM systems, and we told about that in every detail at meetup of Yandex, but actually it could be grouped into the following. As I said before, all the criteria are top level and would translate into some specific requirements, and I will not specify that. Let's get back to the previous report. I may have a look at that at these criteria using the QR code. You can scan that. This is not about phishing, but there is just a link to the Google disk, and this is not just a rickroll. I think that everyone has scanned that. So, Anton, what we know about the solutions that can meet all these criteria? In essence, as Pavel has said, we have identified a set of technical criteria that we are using for the in-house solutions for different solutions, open-based solutions. And as you may see, we now see that there are quite no solutions that would meet all the solutions, all the criteria. What approaches are there if we want to use PAM? So there are two main approaches. First of all, you can make a solution that would meet our criteria, doing that ourselves. And secondly, you take some open source solution that would meet part of the criteria, and you upgrade that. We took the second way. Tell us what you took as the basis. So that's a teleport, an open source solution which is being developed by Gravitational Company, which exists in two versions: open source solution, which you may get from GitHub, and second, that's an enterprise version with an extended functionality that you can buy. We got the teleport open source version. Let me ask a question why actually we opted for teleport in order to make this slide legible. We didn't make a list of technical requirements. And Teleport meets these requirements. For instance, I'm an administrator which loves Apple technologies. How the interaction with the infrastructure would look like. Let me explain that these figures, 2 out of 4, 4 out of 5, 2 out of 2, means that Teleport meets this number of criteria. And thank you so much for your question, Anton. Those who actually never worked with a teleport. So let's assume that some administrator who uses MacBook decided to visit the test machine, and the name of that person is P. Parkhomets, and he decided to visit the test machines the outside teleport. What he would do? He would put TSH, SSH, P. Parkhomets at a test machine, then would get a warning that a platform authenticator would be used, and I will tell you what authenticator is about. And then the system would suggest to follow the instructions that pop up on the screen. As far as Parkhomets is fond of MacBook, the operating system would suggest to do authentication by means of Touch ID. Our administrator would press his thumb against the scanner and would get to the server, where he get a notice that connection is done by means of teleport, that all the actions would be recorded, and certain explanations would be provided as to what privileges that user has in the system. Anton, what conclusions we can make out of how the end-use server is being visited? We can understand how teleport works. There might be several conclusions. First conclusion, I think, is a little bit negative for the teleport. Instead of the conventional SSH utility, you will have to use some TSH utility. That's the Go-based application from gravitational company, which has been supplied along with the teleport. And apart from SSH protocol, it would also run a number of other features, but for administrators, it won't be habitual. The second conclusion that we can make is that the administrator authenticated by means of biometry, by means of Touch ID. The third conclusion that we can make, judging by what you can see on the screen, is that teleport would log all the sessions. And the last conclusion that we can make is teleport enables running the privileges management on the client's servers. This is how teleport looks like, and this is why we took that as the basis. Let me say a few words as how teleport is structured and what concept it follows. Pavel? Teleport has a very simple architecture. It is a model-based, and again, it rests on the clusterization structure. It means that you can put your data in different containers, and you can scale it up by resources and avoid such a problem as a single compromising point. Teleport proxy, that's the first component, that's the entry point to your cluster. So the user would interact with your resources by means of proxy. Proxy will also address a number of other things such as multiplexing of ports, support of tunnel reversing, encryption support, etc. So the second component that we have to mention, that's iOS service. As perceived from the name, that's the service which is responsible for verification of the user data and verification of certificates. Probably you don't know what certificates have been meant, but I will explain that a bit later. Next component, that's the same binary teleport that would be installed on the resources so that you have to grant access to. If you want to grant access to the server, then actually it has to be installed as an extra binary, as an open SSH. If you want to grant an access to web or to something else, then actually you have to install it there, and that agent provides access using native protocols. And the last thing is the distributed database, or etcd, which keeps the data about the whole cluster. It keeps the whole system information that is needed for the functioning of the cluster itself, and also keeps the keys for CE, and I will tell you more about that a bit later. As I said before, the customer would interact with all the end users. He has to do prior authentication. So what is so complex about authentication? Well, authentication, this is a quite mundane thing, and any cybersecurity guy may tell you a lot about authentication, but in terms of teleport, let me specify that so that you can understand actually why we opted for teleport, and you will understand how it works. Before we speak about how authentication has been done in teleport, let me start from a little bit far away. What the SSHD configuration is about. And this is how you do authentication using certain certificates on that slide with lots of text. You may see just an extract from a manual about the trusted user CA keys, and this is just SSHD configuration, and you actually can indicate the path to the key, and the trusted user key would check and verify the data of the user. Let us have a look at that template that you can find in the Managing SSH Access at Scale with HashiCorp Vault, where the guys are telling us about how you may make authentication in Linux distributed system based on certificates. What is going on there? We have HashiCorp Vault, where you actually would get a key. Then what happens next? So let's have a look at figure number 1. It starts from there. We have certain administrator who wants to visit the resources inside our infrastructure. He would generate some cryptographic pair, couple of keys, would make a certificate based on that. After that, the arrow number 2 means that he would have to do authentication that supports hashcode by means of some DC provider or IDC provider. After actually the customer, the user is authenticated, he would provide his certificate, and it would be signed with certificate authority. After that, arrow number 4, the administrator would get his signed certificate back, and then that administrator may serve around the infrastructure, and the SSH certificate authentication verification would check the signatures on the certificates provided by the administrator. There might be a question there. Why we need certificates once there is a usual couple of keys? Well, the certificates compared to keys, and I spoke about that at the Yandex event, certificates, unlike the couple of keys, would offer some extra features. For instance, certificates could be short-lived. So it means that by means of a certificate authority, you can grant a certificate that will become invalid in 24 hours. For instance, once you grant an access to some developer to your infrastructure when the system has failed, but you don't want to let the developers in for a permanent basis. And also the certificate may incorporate a lot of other extra information that could be used. For instance, when you take a decision about whether the user could be allowed for the end server or not. Why actually made such a diversion? Because that system looks very easy, very nice, and this is how Teleport is working. So Teleport acts as a certificate authority instead of HashiCorp Vault, and the users who get authenticated before would get short-lived SSH certificates, and you can use that in order to wander around the infrastructure. Don't hurry up. In essence, Teleport not only works on following that scheme, but for instance, the slides which are the infrastructure of the teleports, there was a teleport node component, but instead of teleport node, you can use OpenSSH as an authenticator, and you can use the scheme when actually the users would use TSH, but instead of teleport node, you would use the classical TSH. Such a scheme has a number of deficiencies, but I will not deep dive into that. So you speak about the authentication at the final nodes, but tell us about authentication at teleport itself. Well, actually, we see how in terms of architecture the authentication has been structured. So let's have a look at what options are there in terms of authentication. Let's answer the question how you can authenticate in teleport. There are two options. So the first option is you can use SSO provider. The second option is without using SSO provider by means of native authentication, which is being offered by Teleport. The second question I'd like to address is how actually you can get authenticated. And in essence, there are two options. The first option, and which is quite obvious, you can use the console utility SSH. The second, you can do that via browser. Teleport allows you to enter Linux infrastructure through the browser. And the third question that could be addressed is what standards are being used in order to authenticate in Teleport. Here we speak about native authentication, so there are three options. The first option, login and password. Certainly this is not suitable if we would like to authenticate people using login password. In that case, we do not need Teleport. The second option, login password and OTP. And the third option, which is most interesting, this is FIDO2 authentication. There is also such a notion as WebL sync. How is it correlated? How is it connected with FIDO2? Well, what FIDO2 is about, so let me highlight that in a nutshell. So that's a set of two protocols. This is VPLSEN protocol, which specifies how relying party, some service that would like to authenticate a client by means of encryption keys, couple could turn to the client in order to initiate such an authentication. For instance, it would specify what API should be provided by the browser to API script so that the authenticating party could initiate authentication using the couple of keys which usually would be stored at some authenticator. And when we looked at how Teleport is working by means of TSH, we saw that they are using internal authenticator. That's a term that we derive from MPLSEM. The second part, that's the setup protocol. Client to authenticator protocol. That's a protocol which describes the specification of how the external authenticator, certain hardware token, has to interact with the client in order to use the keys which have been stored there for authentication for the third party, or for instance on the website. Okay. Let's have a look at the authentication in Teleport by means of SSO through SSH utilities. Okay, let me explain why we opted for the SSO authentication. Because this is the most complex of law authentication. It is not described anywhere. There are certain unclear things, and I had to somehow fix it a little bit. So there are several main steps and several actors in the framework of such an authentication. First of all, we have a kind of a client which is using TSH utility. Then there is a browser, Teleport itself, and we also have some SSO provider, some gate lock, which is connected to Teleport using OpenD Connect or something like that. How the authentication flow looks like? Let's assume that the administrator some John Doe wants to get to some service at that moment. TSH utility would generate several figures, public key, private key, and some secret figure. And then administrator actually would get a notice that the browser would be opened, and the terminal would open up a browser. In order to authenticate at the final browser, you will have to open a browser. So that's quite obvious, it goes without saying. So the terminal opens the browser, and as an input you would get two parameters, public key and the secret. The browser would make a shift to teleport proxy, one of the components of the teleport I told you about, and after that, teleport, getting the public key and secret, would store the data in its database. After that, where let's step aside. After that, a standardized authentication flow takes place by means of SSO. Teleport would do a redirect to the SSO provider, so some key clock. SSO provider would authenticate the client, and after teleport gets the information that really this guy is the owner of that data of that account. The teleport would generate the certificate for the client and would sign that by means of its private key, just like HashiCorp would do using the scheme that I told you before. So teleport would store the secret key, private key, in order to sign the short-lived certificate, which is being used by the client in order to check with the servers. Some variable secret is being used, and then actually the data would get to the client's browser, and actually it would go to the DSH utilities. That means that the client has short-lived DSH certificate that you can use in order to visit the final service. That means that the private key is stored with the client. So that's the essence of the system. This is actually what we wanted to double-check in that scheme. Anton. Again, we have extra flow for authentication through browser. Why is it different, and actually how we can use that to refrain from its use? Well, as I said before, sort of slides before, you can get authenticated at the final server through browser and do some actions in the infrastructure through browser. In case of such a scheme, we'll also upgraded that a little bit. It works the following way. A couple of keys would be generated on the teleport server and would store in the database, along with the private key, because it doesn't make sense to store the private key on the browser after that. Some token would be issued, and this is just a regular cookie. After that, you would use that token to get to teleport proxy, and teleport proxy would do impersonification. It would introduce it as a client. So in that scheme, private client's key is stored with teleport, and that authentication system through browser, I think, is not very much needed, but at the same time, in essence, it allows the criminals to attack the infrastructure, because the criminal may actually use a token to the teleport, and the teleport would be guised with that token, and unfortunately teleport doesn't allow us to disable such a feature. Probably later on we will actually remove these pieces of code. And let's put an end to the authentication. Let's tell the audience why the whole topic was raised. To sum it up, we told you about authentication methods, and we showed to you how you can do that with SSO. Without SSO, it looks the same way, but the authentication is done on the teleport server with no browser or anything like that. The browser-based authentication has one advantage. The user doesn't have to get registered anywhere once you have some SSO provider which contains the data about your employees. But such an approach has a lot of drawbacks, a lot of deficiencies. I will not deep dive into them, but in a nutshell, your stability and security would be impacting the stability and security of your PAM. Compromising of SSO provider would entail the compromising of PAM. Also, there is a number of other technical problems, and there are aesthetic problems. For instance, authentication through TSH utility would require opening up of browser, and Linux users never like that. And so we now know what teleport is about, what architecture it has, and how it authenticates the users. Let's speak in more detail about how teleport authorizes the users, how teleport takes decision whether this or that user can get access to the server. Well, at Yandex event, we said that you can run the access two places. First of all, that's the PAM, the roles that you assign to them, and accounts that you assign to them, and the final host, let it be the Linux Touch IDs. We will not tell you more about that. Let's forget about that, because we will tell you more about that in June at Hylon. And today we will speak only about the PAM, Privilege Access Management. First, let me introduce two notions, a role and a tag. Actually, tag, in essence, this is a line, the key, and the notion which is being stored with the configuration file. There is a role, which in essence is required in order to answer one question only, whether this person can get an access to that resource with certain tags, ABC. So it means that the role opens up an access to the resource if the tags coincide. But by default, there is no regulation. And even there are no recommendations as you can call that role or you can call that tag, what figures have to be there. Well, actually, let me explain why it may trigger some problems. If the infrastructure is huge, if you have a lot of users, you will have a lot of roles. If you don't start introducing some strict rules, hash rules from the very beginning, if you do not set an order to the roles, if you do not bring about some rules how you name the tags, that would be a problem. For instance, we now have about 7,000 roles to provide access to servers and other pieces of infrastructure. Without strict regulation, we would see a havoc, actually. Well, what do you do in order to avoid that pain? When your infrastructure is not huge, or just a couple of hundreds of servers, in essence, you can assign just dozens of roles and that's it. But for instance, once you have to run several dozens of thousands of servers, you have lots of roles and namespaces, and namespaces have been created every day. And you also have VMs, hundreds of them, so the first approach won't be suitable. And we started thinking how we avoid pain following the second way. First, we actually adopted a very strict set of tags, and I will tell you more about that. Also, we adopted convention of naming the roles. All the roles are of certain categories. We have introduced standardized roles in order to execute some rationale as how to manage the users. And then we introduced some processes, and we did a lot of integration. with all our internal systems. Let me add a couple of words. We introduced an automation which checks whether these rules are being observed and complied with once roles are being assigned, and this is how it all works. Okay, first we started with
And the first thing is tags. So we tag everything connecting to teleport. The storage management systems and whatever, even the applications connecting to us. So we have this option. To the right, you can see all our tags, and some of them are mandatory. So they are there with all the resources, and some are not mandatory, so you can skip them. So env the team and name and so on. And we have one tag called owner, and we really need it. And what is cloud? The cloud tag. Well, this means cloud project. I will also talk about it later. We have a private cloud and we manage our access there. Well, before we start discussing our naming convention, and before we start discussing the role formats, let us discuss some requirements we had, because these requirements were important, not only for the naming of the roles, but also for the way these roles will grant access. So the first one was that the role should grant access to only one type of resources, meaning that you shouldn't have a super role which gives access to the databases and to everything. If you look at this role, you will not understand what it is doing. So the role gives access to only one type of environment, say to DLL. And the next thing to understand is that roles can give access two ways. The first one is access to a set of resources based on tags. So you make a sample. So maybe you know this selection process in the cubers. And the other way is using the resource name to only one resource. Another thing is that the role name should explain the access it gives to. And then it should be a regular role, which is a bit long. Okay, what does it look like? It's not really clear. Okay, let me explain this stuff to you. A few words about regulating this. We understand this not only by looking at this, but we also parse them. So the end hosts have a module determining the privileges we provide, and that's why we need our regulations. Okay, there are two formats we ended up with. And maybe you have some questions if you have followed closely. Do you have any questions? Okay, not yet. Okay, we have two formats of roles. The first format, it determines the roles given access to resources based on tags or to a set of resources. And the second format is the role given access to only one resource. Now what's the difference? The number of resources. So in the first case, it's a set of resources, and the second case, it's only one resource. Say we have a contractor and they need access to one host. So we give them access to one host. Okay. And what are the bits and pieces responsible for? Okay. So what is the resource type? The resource type is the type of the resource we grant access to. Servers, BSL or queuers. Then we have the environment, like dev stage. Then we have the team tag. So this is the team responsible for support and administration of this resource. And then we have project and product. They're not mandatory tags, so they provide more details on the resource, so you know whom to ask questions. And the other reason is to provide more pinpoint access. So we have a team of DevOps helping several teams maintain their resources. So the resource of several products. So we can grant access inside one team based on products. And the next tag is namespace, and is specific only for the cubes and for the storage management system. So in the cubes, this is the namespace, and in the storage management system. So this is more information. Okay, then you have the access type. So for servers, you have the pseudo privileges, and for cubes, you'll have read-only, read and write, and some viewer, editor, and admin roles, and the name tag as well, and it is about the name of the resource you go to. For instance, a host name of the server. So here are our end roles. So you can see that these are two roles for the SSH access. The first one gives access to a set of resources, that is all the servers in the prod environment belonging to the media market team. And the next role also provides the SSH access to one server with the hostname market01VB RU. And what is it? SSH minus E minus N, what does it mean? So all the role names are generated based on tags. And we should be able to parse these tags in any other place outside of PAM, outside of the control plane. That's why we have these contractions for all these roles. So E colon is environment, T colon is team, so that we can see it with our own eyes to say that this is the production environment, the host name. So you don't need to go to the description of the role because they have some time to analyze, and this makes it clear what it gives you access to. Okay, so E colon environment prod. So E is about prod, not SH. So okay, hyphens, they separate this. And U colon sudo, this is the privilege we give the user on end host. So we have done it through our plugin authentication module in Linux. And the next thing we introduced was standard roles, which is quite straightforward but effective. We give them to all users by default. So you establish a user and you don't need to do anything because there are some automated roles imposed on this user, and this helps us in terms of logic for managing users in the system. Okay, Pasha. And if you give some standard roles to the staff, it cannot be an excessive step, because all those getting access to teleport, they already have some standard roles giving them some rights. Do you remember the owner tag I focused on? So what does it mean? Every resource has the owner tag, who is responsible for administering and supporting this resource. So here are the roles we have. SSH own. So this gives access by default to the resources where you are indicated as the owner. Okay, all you need to do is connect a resource, say that you are the owner, and then in teleport you can see this resource and you can connect to it. Why did we do it? Well, just like many other companies, we had a lot of IT mess because there were many keys with many different people. Everybody had some kind of messy access and everybody was happy with it. So we decided the connection process to connect our infrastructure to teleport to make transparent and visible for admins, because they were used to SSH and here they need to install things, to order roles, to describe the access. It didn't look convenient, and the standard roles mean that, okay, you roll out the teleport for 1000 servers, so you can see that they're all there, they're connected, and then they would disconnect from SSH, and it worked fine. Okay, what do you mean that you get them by default? Okay, we have our own custom admin for teleport. We generate users through a custom rather than standard admin. So when we create a user, we also give them a lot of custom fields like the identifier of the worker and so on. And the user has these roles provided by default. In the past, we had to go to admin and send roles independently, but now we have automated these things, and the usernames are also generated by default. Okay, we have processes around this. We have automated role creation, and to obtain them, you can send a request to the service desk. We have many processes around it. Well, they are not too sexy, so we will skip them. Okay, thank you. So now we understand how teleport works, how authentication is supported, how our custom role model works. Okay, can we really integrate it with real infrastructure? It looks too sophisticated. Okay, just like any other big IT company, we have a heterogeneous infrastructure, and a big one. So in the past, we had a lot of virtualization systems which were not connected. We had a lot of bare metal and bare metal tools. We had our internal private cloud living in parallel with proxies, and we have a lot of cubes. And the first strategically important step was to change the process of virtual machines run in Prospects. So the virtual machines, they have the tags attached by default, and they connect to teleport. Okay, so we have the proxmox with the virtual machines. We have the provisioner. So, and it installs the virtual machines, and we have the netbox. And there we have all the information about hosts, including the tags the hosts should have. So when a machine is created, the provisioner goes to netbox, takes all the tags, goes to the prox, creates the machine, and when the teleport agent is launched, there all the tags are attached. So the machine connects to the teleport agent with the tags required. Okay, I'll talk about teleprox a little bit. So we have our own Flask run microservice. It gives us one interface to create virtual machines in all our proxies. What is it about? Well, this is just an HTML form to solve a few problems. It asks the user to set mandatory tags, the owner, the image you're going to use, and so on. Then it brings them to the netbox and creates virtual machines in the proxies. So you go to teleprox, you order a machine, you say that you are the owner, and so on. So this way you can change the newly created virtual machines. Okay, we did the same for bare metal. So all our bare metal today is created with the tags required and connected to teleport in an automated way. So the users, the owners, can have access, and those who have ordered the roles, they can also have access. And the final step to integrate the server infrastructure was integration with a private cloud. And for this, we developed the Cloud Inito daemon, which is launched with the startup of the virtual machine. And then it goes to the metadata service, takes the tags necessary, and attaches the tags to the teleport agent. And this way we know who the owner of the virtual machine is, and we know where it is launched, in which cloud project. That's why we needed this tag cloud. Okay, a question. Virtual machines in a cloud are usually in an isolated network, so outside of net. And here you can see the connection between the teleport and virtual machine. So how do you connect them? Thank you. This is a tricky question. Okay. So we start up and connect the virtual machines. So this process is different in many ways. And as Anton rightly put it, the whole cloud infrastructure is beyond the net. So what do we do? All the machines created in the cloud connect to the control plane using the reverse tunnel. So the machine at the startup level creates this tunnel, and the user gets there through this established tunnel. So we know who the owner is of almost all the resources. We can give them all access in an automated way. And we have many cubes, and namespaces are created in batches daily. And with the DevOps, we agreed like that. When we establish namespaces, we create roles for access. So you take the namespace name and all the roles possible, so read-only or read and write. And the users will need to order the roles. And our latest integration is with messages for alerts sending with the HR services to withdraw access for those fired. Okay, we have built a teleport with a lot of processes. Okay, Anton, how can you further deal with it? Okay, how can you bring the teleport into the company management system as a whole? How the VPN plus teleport architecture can work in an abstract case? Let's imagine, okay, the next slide. We have a user who wants to connect to some internal admins and internal web resources. So what can we do for this? We can bring them all together. We can have some private balances in Jinx and give VPN access to these balancers only. So this way, those who don't need any privileged access can only make it to the web resources which are behind these balancers, and there should be some further authentication. Okay, and if you need a different access, like admins. Okay, that's where we use teleport. We put the teleport proxy. We have access from VPN to teleport proxy through one port 443. Why one? Because teleport proxy has this great feature like multiplexing ports. So the admin connecting to the port can use port 443 and then get access to the databases and to the Kuber clusters and virtual machines. So you don't need to open many ports into the internal infrastructure. And this type of infrastructure matches the defense in-depth approach. So the threat actor who wants to make it to the privileged infrastructure like service would have to go through several protection layers. The VPN authentication and the teleport level authentication. An important note. You might be tempted to make authentication in teleport and VPN based on one SSO to make it convenient for the customers. So this way you will lose the advantage I have talked about, because in this case the threat actor to compromise your infrastructure will have to compromise your SSO provider once, and VPN and teleport will not have to be compromised. So this is not the way to go. Okay, and how can you build this threat model? How to understand how this PAM can be cracked or worked around? Okay, we have talked about the integration of teleport, how it can be built into your infrastructure so that in your lifecycle you don't lose servers. How to integrate VPN with teleport to have a full-fledged architecture. And now let's talk about the way you should protect teleport if you want to use it as a core for your PAM. Okay, talking about threat models, we should start with the threat actor model. So there are two here for teleport. The first one is the external threat actor, and you can cut them off by removing teleport behind VPN. In the documents, they say you can put the teleport proxy in the internet. That's not what we do. We want it to be behind the VPN to make life more difficult for the external bad actors. And the second category of bad actors is the internal bad actor, and they can be different. They can have access to the network without the credentials with teleport. They can have access, and they can have credentials with teleport. They can have access to the server's management interfaces or access to the racks. Okay. Now let's talk about the way to support and harden the teleport. We should remember the teleport architecture. There are two major components to it. The first one is control plane, which supports the functioning of the system, and the second part would be the end hosts, the servers, the databases, the Kubernetes clusters, where you have teleports and which we protect. And the third one, talking about hardening, would be like that. When you have teleport and you use it for authentication, then you can use a SOC and to add various alerts for suspicious authentication or related events. Let's talk about hardening the control plane. When we talked about the teleport architecture, we mentioned that teleport uses a distributed data, etcd, and in etcd they store the private code for the certificate authority. What does it mean? It means that compromising etcd, they will compromise your whole infrastructure protected by teleport. So etcd should be protected well. Yeah, one more comment about etcd. How to protect etcd? There are many articles on this. Well, briefly, you should support authentication in etcd using Intel LS, using certificates. Say the else service goes to etcd only using certificates. So in teleport out of the box you have this, more or less. The second thing to pay attention to is network isolation for the etcd ports. So you should make the parts of your base, the replica, to see each other in the network, and the port application shouldn't be visible to anyone inside the infrastructure, and the port the auth server is using for configuration of etcd should be available only from the local host. And the next thing is the protection of KVM. So if you have hardened etcd well, but in your infrastructure the access to the servers supporting teleport can be accessed through the management servers, the pen tests often show us that the password for KVM is admin or admin123. So then it means that the threat actor can get access to the private key. So where you deploy the teleport, the control plane of teleport, so in this service you should protect the control plane of the teleport. Network installation. It means that the control components of teleport, like service and proxy and nodes, they should be isolated using some local firewall or some other firewall you use, so that they should be available to those who shouldn't have access to them. The next item, which is also self-explanatory, etcd stores data on the file system of the server where it is deployed. And in the life cycle of your infrastructure and your cluster, your servers will be sometimes replaced, like some disks will fail. And the DC owners don't destroy those disks properly sometimes. So if you don't encrypt properly the teleport deployment with service, so when the disk fails, it will be thrown away and not destroyed, and your private key can be leaked this way. So please pay attention to this. And another thing, which should be number one, by the way, is that you can deploy a teleport in Cube, in virtual machines, or in bare metal. So we suggest it should be deployed in bare metal. So if you deploy it in Kubernetes or in a virtualization system, then the control plane of this virtualization or Kuber systems will expand the attack approach. So teleport is super critical in terms of access management. You should try to avoid this. Okay, access control to the hosts and control planes. So if you have made everything secure and encrypted, but if the host or control plane have access or give access to anyone, then that's not a good story. So you should let there only some dedicated admins, and they should be identified using the SSH keys stored in hardware tokens. So we should deploy the hosts using various configuration standards for security, and you should also cover all this with security monitoring, like a Square or something else. And you shouldn't forget about one thing: the security guys like installing monitoring hosts in the infrastructure. They can also run codes on the and servers. It's more convenient to investigate incidents this way, but this monitoring agent can be a vector for compromising the private keys of security authority. We use a Square, and the Square deployed to the telecom host, so there we used a PAM appropriate to prevent access to the teleport files. The second part to harden would be the end hosts. So the servers where teleport node is installed. And here you have an interesting thing. Teleport node doesn't support TCP wrap. Well, this is a mechanism used by the unknown host allow to reduce access to Linux daemons through the network. So for teleport node, you cannot have the host allow config to grant access to teleport node from your local network. So this is not going to work. That's why you should find some workarounds here and to block access to teleport node at the border level or firewalls, local or internal ones. You should also remember that you have the listen address when you configure. So we have the interface listening to your teleport node, and you should make it a local interface of your network, so that your teleport nodes shouldn't stick their head into the internet. Hardening of OpenSSH. So why are we talking about OpenSSH if we're talking about teleport? Maybe you would like to use OpenSSH as a mechanism, and for this you should properly protect it and write a config for host allow and for SSHD, so that you don't have access from any other places. Okay, summing up, I'd like to say that even the best teleport, considering all the things we have mentioned, so if we have integrated it with our infrastructure, it is not our dream PAM. Teleport is still a framework which can be used as a base for building a good PAM. Okay, Pasha, a few words on what we have done with teleport to make it more nice to hear. Okay, we added a lot of functions there. We integrated it with a lot of our services, and next time I speak, I'll talk about our customized admin, about our customer PAM module for privileges management, and so on. And you can have some questions in terms of scalability. Yeah, we have more than 10,000 hosts now. This is an absolute picture, and for 10,000 hosts, so if you have one cluster deployed for various DCs, well, it's going on okay. We have some issues, we'll mention them when we speak at high load, but overall things are fine. We are getting along well. And by the way, we hire people. Okay, we're around. Yeah, we'll go there. So our time is up. So we will take your questions offline. Thank you.